All right, so we've got the period, we've got the domain, the range. Okay, range has to do with y values, and I am noticing that they've got the arrows up at the top, I've got arrows at the bottom. And in fact, when I drew this line, like, I didn't pick up my pencil at all. So I didn't skip any of the y values. And I've got arrows at the top and bottom, meaning it's gonna go up forever, down forever. My range is going to be all real numbers. You can either put it that way, or you can say from negative infinity to infinity, same thing. All right, so vertical asymptotes actually have a lot to do with the domain. So my domain included everything except for where I had those vertical asymptotes. So the vertical asymptotes are pretty much going to be, instead of x doesn't equal, x does equal pi halves plus n times pi. Like the vertical asymptotes are what I had to skip in my domain. So those are very similar. X-intercepts, let's see, I hit the x-axis once right there, right in the middle of those asymptotes, right in the middle of this asymptote, again and again and again, which it looks like it was at negative pi, and then at 0, and then at positive pi. So it looks like it's happening every distance of pi. So I'm gonna put, you know, I put an n pi right there, like some number of pi's, 1 pi, 2 pi, 3 pi. I'm gonna do the same thing here. I'm gonna say n pi is the x value, and then 0, of course, is the y value on my x-intercepts. Every number of pi. So here's, I mean, you can put a number in, I can put like a 5 in. At 5 pi, I should have an x-intercept. Oh, Dylan, this is at n pi. Here, I'll zoom in a little bit. Is that better? Yeah, so these are both n pi, some n number of pi's. Now those n's, by the way, those are like 1, 2, 3, 4. It's not, I'm not gonna have like a 1.5 pi. It's, excuse me. It's an integer number of pi's. And then my y-intercept, you can only have one y-intercept, and it looks like my y-intercept was right here at 0, 0. All right, and the last bit of information here is the symmetry. It's symmetric about the origin. In fact, I'm going to also say that this is an odd function. We've talked about even and odd functions. This is an odd function in that, well, the fact that it's symmetric about the origin kind of tells us it's an odd function. What was that?
What would be an even function if you just look at the graph?
An even function would be symmetric about the y-axis, like a parabola or something like that. All right. All right, so here's our tangent graph. This is like the parent function for tangent. Once we know the parent function, we can do all of the transformations. You can shift this, stretch it, shrink it. You can do a reflection. If we know the parent function, we can do all that kind of transformations. All right, so what they're telling us down here is the vertical asymptotes of the graph can be found by solving the equations where, see the stuff in parentheses here, bx minus c? Whatever's in your parentheses for tangent gets set equal to, let's see where they came up with these. It got set equal to a negative pi halves, which I had an asymptote at negative pi halves on the parent function, right? And then I could also set it equal to a positive pi halves. And on the parent function, I had an asymptote at the positive pi halves. So I'm pretty much going to set that stuff in the parentheses, stuff that has to do with the x. I would set it equal to what the original asymptote, where the original asymptotes were, and see if we could adjust it. All right, so what that means here is, notice that the bx, again, bx minus c is what I was taking the tangent of. And in this case, I'm taking the tangent of x over 2. So I can set my x over 2 equal to the negative pi halves. And I can do x over 2 equal to the positive pi halves. I'm going to solve for the x, and it's going to help me know where my asymptotes are. So like if I multiply by 2, all right, it looks like x equals a negative pi. So I have a vertical asymptote at negative pi, so like right here. And then the other one, if I multiply by 2 on both sides, x equals a positive pi. So I have a vertical asymptote over there at the positive pi. Which, okay, here's what I'm thinking. Dividing by 2 on my x, oops, that pretty much made me double. It kind of did the exact opposite. Usually when I divide by 2, and, I cut it in half, but it made me do the opposite. It made me like double how far apart the asymptotes were. Like they used to be over here at negative pi halves and positive pi halves, but we kind of doubled it. So like got a lot wider. I still think it's going to have the same basic shape. I think it's going to look, look something like this. Let's get some specific points that we're going to hit though. Maybe I'll plug in like a, let's go negative 3 pi fourths, negative pi halves. Let's get some negative pi fourths. Go with 0, positive pi fourths. You get the idea here. Let's get the shape of this. All right, so let's see. I left off at, I think Adam, you lost one, right? So then, Fiona, will you plug in the negative 3 pi fourths? Do tangent of that x value. So Fiona, you got the tangent of negative 3 pi fourths over 2. And then, let's see, Jackson, you're at home, right? Jackson, will you plug in the negative pi halves? So tangent of negative pi halves over 2. All right, nice. So yeah, make sure you're plugging it in to the tangent of x over 2. All right, and then Shire, will you plug in the negative pi fourths? All right, make sure your calculators are in radians, all right, guys? I've got negative pi fourths radians. And then Sky, I think you're at home today. Will you plug in the 0? And then let's see here. Ryan, you're at home today as well. Will you plug in the positive pi fourths? All right, Fiona, let me know what you got. Oh, okay. Let's check that out. Jackson, you got a negative 1? Okay. All right, so Fiona, you were putting negative 3 pi fourths in? Yeah. And it was that x over 2, so like, so is this like what you got, this messy decimal? Oh, okay. All right. And then Sky, I think you got the, wait, Shara, did you do the negative pi fourths? Okay, what'd you get?
I got negative 4.41. Yeah.
negative 0.414 like that, which it looks like, Ryan, you got with your positive pi force, you had a positive 0.414. Nice. All right, and then let's see, I already got this one was a negative 2.414. All right, and then let's see here, Sky, I think you had the 0, right? Nice, so you got the 0.00. Let's see if this looks like, you know, what I'm thinking is going to be is a horizontal stretch. Let's see if that's what it did. Negative 3 pi force, I got negative like 2.5 kind of. It's like around here. And then at negative 1. Still in the negatives here. Then 0, 0. Then I go to the positives. Okay, so I think I'm going to get, if I keep this going, if I go to like a positive pi halves, I'm probably going to get just a positive one, like a positive value of my negative pi halves y value. Let me get that to a positive 1. And if I go to like a positive 3 pi fourths, it's probably going to be, again, like a positive 2.414. All right, and I'm thinking it's probably going to have this type of shape that I had on my parent function, just like a bit wider. Still has to stay inside the asymptotes, so it's going to get that, going to have that arrow. Connecting these here. All right. So that's one of the cycles. And then if I kept this going, I would repeat it again. It would go all the way out to, this would have to go, this is a distance of 2 pi now, right? I'd have to go out to like 3 pi for another asymptote at 3 pi, and it would have like this same shape. That's just one of the cycles. I got one of the cycles. Okay, any questions? No, you guys got this. Okay, which as long as you have the parent function, I think you can find the rest of it. This one, what just happened here? Oh, sorry, that's not supposed to be tangent right there. Sorry, you can go ahead and erase that. It's supposed to be y equals negative 3 times tangent of 2x. My bad, my bad. All right, so I'm gonna give you guys a second. Find where the asymptotes are first. I'd find where those asymptotes are, and then pick some x values within the asymptotes. Let's see if you can get the shape of this graph. All right, so Erica, whenever you're ready, will you let me know one of the asymptotes? Erica, did you hear me? Will you just let me know so I know you heard me? All right, cool. All right, so Erica's gonna give me the asymptotes, and then Francisco, I'll have you give me some points between the asymptotes. All right, so Erica, you're doing like I have in blue here. So whatever you're taking the tangent of gets set equal to a negative pi halves and a positive pi halves. So Erica, do you have one of them yet? Okay. All right, so let's see, you got your pi fourths. This is the stuff that I was taking the tangent of. Equal to negative pi halves divided by 2 on both sides. And yeah, we got negative pi fourths. Nice. And then you said plus pi halves. Pi times n over 2. Nice. So like, that's very technical. Nice, Erica. What that means is, here's my asymptote at negative pi fourths. And my other one, if I do 2x equals a positive pi halves, divide by 2 on both sides, and I get a positive pi fourths. And so you put plus pi over pi times n over 2, which is perfect. This right here is a distance of pi halves. So you said you had to do like pretty much every pi halves. When you say plus pi times n over 2, it's like every pi halves. So like then I have another asymptote right here, still a distance of pi halves away. Nice. And I have another asymptote right here, still a distance of pi halves. In fact, even if I go on the other side, a distance of pi halves, I get another asymptote. All right, so there's like all the asymptotes. All right, and then Francisco, I was gonna have you plot some points between, let's do just like this middle section right here. All right, so Francisco, can you give me points in there?
Yeah, I just kept getting 0 and undefined, so I don't know what I'm doing.
So the 0.00, yeah, and the undefined I think is the asymptote. So did you get undefined at pi fourths?
Yes.
Okay, so let's pick something between 0 and pi fourths. Maybe pick like pi eighths or something like that. Like pick something between these guys.
I got -3 for pi eighths.
Pi eighths,
Mm-hmm.
you said a -3?
Yes. -3.
Nice, and then try the negative pi eighths.
I got 3.
+3, okay. So an eighth is half of a fourth, right? So it's like halfway through here. I was hitting at a +3, and then this goes down to a -3. Oops, I can count to 3, I swear. All right. And it's not going to be a straight line. It's going to be that curve that approaches, it gets really close to the asymptotes, but doesn't actually cross it. All right, now, let's see. These 3's that you got, that's probably because this -3 out front, the negative itself gave us a reflection. In fact, a vertical reflection. Like it used to be going like this, right? But it's got that vertical reflection. It like flipped upside down. And then the 3 was a vertical stretch by 3. It's like they grabbed onto my parent function up here. It's like they grabbed onto this parent function and like dragged it up and down. They like stretched it out. It got like skinnier, right? And in fact, it's you can't really see all the curve. On the parent function, I can see that curve. On this one right here, it almost looks straight. It's because they stretched it out so much. Okay, any questions? So for the -pi8, is that what you're talking about?
Yeah.
Okay, so this is what I would put in my calculator. First of all, my mode is in radians, and then I'm going to do a -3 tangent of 2 times x, and my x was -pi8. All right. So that's where we got our 3 there. All right. All right, looking good. Any questions on this stuff? Hopefully we kind of have this in our head, like what I'm expecting to see. I'm expecting to see a reflection. I'm expecting to see like a stretch. And then when I plug in those points, it's like, okay, yeah, now I'm getting specific points that hit the reflection and the stretch. Let's look at, all right, if this was pretty much all tangent, right? Let's take a look at cotangent. So tangent is sine over cosine. Cotangent is cosine over sine. It's like the reciprocal of tangent. So it is also an odd function. Can somebody remind me what an odd function is again? Yeah. Okay, around the origin. So it's got like this guy up here, symmetry over the origin. It's like an odd function. It has symmetry around the origin. All right, nice. And then, so your cotangent will have that same symmetry. Couple things that'll be different though. It's got different asymptotes. Notice that I'm dividing by sine of x. So where the asymptotes are on this graph is going to be a little different. All right, I find the asymptotes by setting this stuff in the parentheses, not equal to negative pi halves and positive pi halves, but equal to 0. Oops. Set it equal to 0 and pi. The original asymptotes are at 0 and pi. So here's 0, like right on my y-axis. Got an asymptote there. And then at pi, an asymptote there. Yeah, Dylan, we can do that in a bit here. Give me a sec here. All right, so the period is the same as tangent. This is going to be a period of pi, which again, look at how far away the asymptotes are. Those go from 0 to pi. That distance is pi. So that's the period, how long it takes before it starts to repeat. Now, the domain is going to be very similar to your cotangent. The domain was all the x's except for the ones where you had the asymptotes. It's just that our asymptotes are a little different. So on this one, on tangent, it was all x's that do not equal pi halves plus n pi. And this one is all x's that do not equal like a 0 plus n pi. So I'm just going to say n pi. So like there's an asymptote at 0, there's an asymptote at 1 pi, there's going to be an asymptote at 2 pi, there's going to be an asymptote at each n pi. Even negative, like if I go to negative 1 pi, negative 2 pi, so I've got asymptotes there. So those are not in the domain. Everything else is in the domain now. Okay, range, same as tangent. It is all real numbers, or you can say negative infinity to positive infinity. Vertical asymptotes. The vertical asymptotes are where I restricted the domain. So the vertical asymptotes, instead of x does not equal, it's going to say x does equal n pi. Like I had a vertical asymptote at 1 pi, I had one at negative 1 pi, I have one at 10 pi or 500 pi. At any, again, it has to be a whole number, positive or negative though. At any n pi, I get this vertical asymptote. All right, x-intercepts. My x-intercepts are going to be similar to tangent in that it's right in the middle of all these asymptotes. Okay. So this is going to be over and over and over again. It'll be at every, oops. See, I got a pi halves right here. And then every number of pi after it. So pi halves, and then I've got 3 pi halves. Like, see this distance of pi again? Every distance of pi, I get another x-intercept. So some n number of pi's. And then the y value is 0 every time. Alrighty, y-intercept. Do you guys see anything about a y-intercept here? No? No, as in you don't see it, or like it's not going to happen? Oh, it's not going to happen. The y-axis is an asymptote. I can't hit the y-axis. So I have no y-intercept. But the symmetry, this is symmetric about the origin as well. Which in other words means it's an odd function. Okay. So this, I'm gonna plug in a few points again. It's gonna have a very similar shape, you guys. It's gonna hit like the 1, and it's gonna get really close to the asymptote. Doesn't cross it though. All right, goes down to the negative 1. It's really close to the asymptote, but does not cross it, okay? And that's just one of those cycles. It's then going to hit the same thing again and again and again. So I will do that, you know, in this other part of the asymptotes. Over and over and over. All right. Okay, any questions on my cotangent graph? Question on the cotangent graph. All right, so Dylan, I'm gonna go off to the side here real quick. Just a refresher on even and odd functions. I'm going to draw a little example of each. If I have an even function, I think the one we're most familiar with are parabolas. An even function, if I fold it in half on the y-axis there, it is totally symmetric on the left and right hand side of the y-axis. And then you've got an odd function, which I think we're probably most familiar with x cubed. Well, let's see here if I can draw this. All right. And I can't really fold it in half necessarily, but if I rotate it 180 degrees around the origin, so if I pick a point here, if I go half a circle around the origin, then I would land on the other one. In fact, if I take that whole graph, rotated 180 degrees around the origin, it would land on the same exact graph. Okay, so that's the difference between your even and odd functions. Yeah.
So I might have done this wrong, but whenever I plug any of our x-intercepts with my calculator, it all came out as errors.
For which one are we doing? Tangent, cotangent?
Okay.
How did you put cotangent in your calculator?
1 over tangent.
1 over tangent, okay. And what did you sub in? What number of radians were you taking the tangent of?
I took the tangent of pi half.
Pi halves, okay. Oh, okay. So here's why. My tangent of pi halves in my calculator, what's tangent of pi halves in my calculator? Undefined, right? So my calculator is trying to do 1 divided by undefined. Does that make any sense? So let's try something that's not undefined. Let's try like a pi fourths right here. All right, so there we go. I got that positive 1, which at the pi fourths, that was hitting a positive 1. So I think that makes sense. But was the pi halves throwing you off? Okay, all right. Good question, good question. All right. How are we doing, guys? Tangent, cotangent, any questions? No, we're doing all right. Let's see, how far are we? All right, yeah, we're about halfway. I'm gonna do one more and then we'll call it a day. This one is 2 times cotangent. So we basically got our cotangent parent function. This is like my basic cotangent, but this number 5 here, it's got a couple of transformations going on. This is gonna be a vertical stretch by 2. And then this usually dividing by 3 makes things smaller, but we are actually going to have a horizontal stretch by 3. Okay, so let's see what that looks like on our graph. I'm going to see the asymptotes were at 0 and pi. I gotta do the bx minus c, whatever I'm taking the cotangent of has to be set equal to 0 and set equal to pi. In this case, I'm taking cotangent of x over 3. So I'm gonna do x over 3 equal to 0 and x over 3 equal to pi. That'll help me figure out where the asymptotes are. So like if I multiply by 3 on both sides, it looks like I got x equals 0. I've got an asymptote at 0. And if I multiply by 3 on both sides here, x equals 3 pi. I have an asymptote at 3 pi. Okay, so this is going to be pretty spread out. Asymptote at 0 right here. Here's my 1 pi, 2 pi. I gotta like keep it going out to 3 pi. All right, there are the asymptotes. Now I'm thinking if I did this right, I probably have let's see, I probably have my x-intercept in the middle of these guys. Oh, I kicked us out. All right, but I would put my x-intercept at 3 pi halves, whatever's in the middle. And you can even plug in, maybe I'll plug in like a pi halves, a 3 pi halves, maybe let's see here, maybe 5 pi halves. I plug in some x values and see what I get. All right, it kind of kicked me out, so we'll have to pick this up next time. So what this means is